I'm absolutely thrilled you're here today because we're going to dive into something that honestly sounds like pure science fiction, but it very well might become our reality. We're looking at CERN's proposed mega machine. It's this mind-boggling feat of engineering that's literally designed to help us figure out the ultimate fate of the universe. So, if you've ever wondered what actually comes next after the biggest discoveries in modern physics, you are definitely in the right place.
All right, let's just dive right into our agenda. We'll start off with Part 1, the next great physics mystery. Then, Part 2, Meet the Future Collider. After that, Part 3 covers the cost and the footprint. And we'll wrap things up with Part 4, The Public Gets a Say.
Okay, Section 1, the next great physics mystery.
To really grasp why scientists are pushing for a massive new project, we have to look back at the catalyst. And that is the Higgs boson, discovered back in 2012 at CERN. It's arguably the simplest yet most perplexing particle we know of. It relates to the very mechanism that allowed elementary particles, like electrons, to actually gain mass. I mean, picture this. Just a tiny fraction of a nanosecond after the Big Bang, this mechanism allowed atoms to form. And because atoms could form, larger structures could form. It essentially brought our physical existence into being.
But here's the thing. Finding the Higgs wasn't the end of the story. It was actually this spectacular new beginning. As CERN's own feasibility study points out, the Higgs boson may be directly connected to the ultimate fate of the universe, and it could shed light on so many unsolved mysteries in modern physics. The tools we have today totally push the boundaries to find the Higgs in the first place, but to study its far-reaching implications, well, physics needs a new, much more powerful lens.
So, moving right along to Section 2, Meet the Future Collider.
So what is the macro solution CERN is proposing to solve these lingering microscopic mysteries? It's a project currently under study called the Future Circular Collider, or the FCC for short, and its proposed circumference is a staggering 91 kilometers. Just to put that into perspective for you, you could easily fit the entire city of Geneva inside of it. It's an absolute titan of a machine designed to eventually take the baton from the current 27-kilometer Large Hadron Collider sometime in the 2040s.
Now, where exactly do you put a 91-kilometer ring? Well, you bury it. Specifically, down at an average depth of 200 meters. This immense machine would sit deep beneath the Haute-Savoie and Ain departments in France, as well as the canton of Geneva in Switzerland. After running the numbers on over 100 different scenarios, scientists settled on this preferred layout, which would feature 8 surface sites and 4 experimental areas connecting all the way down to the ring.
Scientifically speaking, the research program relies on a pretty ingenious two-stage plan. Stage 1 is an electron-positron collider. Think of it as a Higgs factory that would deliver results with just unprecedented precision. Then, later down the line, the facility would transition into Stage 2, which is a proton-proton collider operating at a massive collision energy of around 100 tera-electron volts. It's a brilliant two-step approach that maximizes discovery and perfectly aligns with the top priorities set out in the European Strategy for Particle Physics.
Now, you might be thinking, okay, this all sounds like abstract physics, but it really isn't just about the fundamental structure of the universe. The technology required to build something on the scale of the FSC pushes the boundaries of everyday innovation. Developing these particle colliders directly leads to breakthroughs in superconducting materials for medicine, advanced fusion energy research, highly efficient electricity transmission, and medical accelerators. These are super tangible societal benefits that ripple right out from the pursuit of pure science.
Which brings us to Section 3, the cost and the footprint.
Whenever we're dealing with an underground megastructure, we have to look at the highly practical logistics. The estimated construction cost for that first stage, the electron-positron collider, is 15 billion Swiss francs. That massive figure includes the whole shebang: the tunnel, the civil engineering, the technical infrastructure, the accelerators, and the 4 detectors required to run it. It's a huge number for sure, but it reflects the totally unprecedented scale of the engineering involved.
But the crucial point here is how this actually gets paid for. This 15 billion franc investment wouldn't be just one giant upfront check. It'd be distributed over a period of about 12 years, starting in the early 2030s. And very much like the construction of the previous Large Hadron Collider, the majority of the funding would actually be absorbed by CERN's existing, regular annual budget over that decade-plus timeline.
On top of that, CERN has made some really strong commitments regarding the facility's footprint. The feasibility study is clear. Any new project has to be an absolute exemplar of sustainable research infrastructure. That means integrating eco-design principles from day one, literally from design through construction right down to eventual dismantling. The goal is keeping the environmental footprint exceptionally low and developing what they call territorial synergies. A great example of this is capturing the immense energy generated by the facility and actually reusing it to benefit the local communities above ground.
And that leads us perfectly into Section 4. The public gets a say. Because before any green light is given to start digging a 91-kilometer trench, everyday citizens are actually being asked to weigh in. These public consultations are happening right now. The FCC is still very much a project under study, and CERN is extremely dedicated to transparency here. Over a 4-month period stretching from May to October 2026, there are workshops, site visits, and public roundtables taking place across both host states. It kicks off in mid-May in Geneva for Switzerland and early June in Arkham for France.
What's really interesting is how these transparent dialogues are uniquely structured to respect the democratic frameworks of each host state. Over in Switzerland, the consultation operates under the guidance of expert third-party guarantors. Meanwhile, in France, the debate is run under the highly formalized Commission Nationale du Débat Public, or the CNDP, which is basically the most important form of public participation in the country. It's all to ensure the public can genuinely discuss the project's evolution before a single thing is finalized.
So, when you put it all together, the timeline we're looking at is just massive. It kicked off in 2012 with the discovery of the Higgs boson. Over the last couple of years, in 2024 and 2025, the massive feasibility studies were wrapped up. Today, in 2026, we're deep into the public consultation phase. But here's the vital takeaway for us today. The CERN Council will not make a final approval decision on whether to proceed with the FCC until 2028 at the earliest. And if it does get approved, they're targeting the 2040s for activation.
Which leaves humanity with a really profound question of science, economics, and, ultimately, curiosity. Knowing the mysteries that still remain since the dawn of the Big Bang and understanding the sheer scale, the cost, and the societal benefits of this massive machine, should we invest 15 billion francs over 12 years to uncover the final fundamental secrets of our universe? We'll have to wait until 2028 to see what the CERN Council decides, but I really hope this explainer has given you a clear, structural understanding of exactly what's at stake here.